What's up, y'all? Big Snoop D-O-double-G. I want to welcome y'all to my house, the dog house. Slide in.
I've gotten a number of comments over the last little while where people have asked if I can show off my Linux desktop setup as well as what I'm running on my server. So today we're going to do an MTV Crib Tour 2024 Hoff.world. I'm going to take you through my setup on Linux on the desktop, my server infrastructure, all the services I'm running, some of the custom stuff I've made. It's going to be pretty sweet. This bad boy right here is critical for all of my daily operations. It is in a Cooler Master Silencio S600 case, which is dead quiet here in the living room. You can barely hear it at all. There's a little bit of ventilation on the bottom where it gets airflow from. Got a little bit dusty, so I should probably clean that at some point. But it's a good little case for a server. I'll go ahead and pop the side for you guys so you can have a look at the guts of this thing. I'll run over the specs as well real quick. So we're rocking an AMD Ryzen 9 3900X, which as you can see right now is being cooled by the Noctua D9L. It's a really performant little thing. I've got 32 gigabytes of DDR4 in there, and I've got 3 hard drives that you can't see, plus an SSD that are down below that little bit there. As for power, it's a Seasonic 80 plus gold fully modular power supply, and I'm running an MSI X570 Torpedo motherboard. It's pretty sweet. Okay, we're over here on my desktop, and I'm just going to show you guys my host name naming convention real quick so you can get an understanding of what I'm talking about here. So my jails and containers and virtual machines are named after Pokemon games. So I've got Crystal, Ruby, Sapphire, Emerald, etc. Down here are my actual bare metal hosts, and those are named after towns and cities from Pokemon games. This is actually RFC 1178 compliant, so don't at me. For obvious reasons, not all of these hosts are up at one point in time, so I'll go over the ones that are interesting to us today. So all of these ones up here are running on my server, so they're up 24/7. They are containers, well, jails since I'm running FreeBSD, and I'll get into that later. But they're jails that run various services and things that I like to keep containerized. Down here, the most interesting one is Sunnyshore, which is the computer that I'm on at the moment. It's my desktop PC. I'll do a little spec reveal in just a second. Lava Ridge here is my server, so that's the one that all of these containers are running on. What else have I got here? Interesting. This is an AI compute server I've got, not always on though. What else is interesting here? This is a home theater computer, another home theater computer. This is a Surface Pro that I keep on my desk, which I'll show you in a second. This is a Raspberry Pi that is actually over by my bedside, and we'll get to that also in this video. I'm pretty excited to show you that. This is a Raspberry Pi that's on my other desk over there, which is also very exciting. And then finally, this is another Raspberry Pi that is sitting on this desk right here, and I'm really excited to show that to you guys as well. But for now, I'm going to go to the main server first, and we'll log on to Lava Ridge. Alright, so we'll just do a cheeky SSH Lava Ridge. I have a ssh.config that basically does everything for me, like behind the scenes, so it configures the port. Obviously, I'm not running it on 22. It configures the port, pub key authentication, etc. But with my servers, what I like to do is get them to print out a little ASCII art of like a Pokemon that's themed to that town that it's named after. I think it's pretty cool. So Lava Ridge to me is from the Hoenn region, and I associate Flygon, this Pokemon here, with the Hoenn region. If you want to know how I ended up doing this, you can check out my Linux server setup video where I go over the tool I use in a chapter right at the end. But essentially what we've got here are my pull listings. So this is actually a custom script that runs. It's located in /extra /amotd.sh. So that's like admin message of the day, right? The folder /extra, why did I choose that? If you know, you know. That's all I'm going to say. Here, this is my admin message of the day. So literally it's very simple. I just do uptime, print out my pull listing, do what jails are currently up, and then I do my jail mount points if I've got them. I don't have them commented in because I don't necessarily want you guys to see everything here that's going on, but it is what it is. But yeah, so this is pretty sweet. Over here I've got my Z pools, right? So Blackthorn root, it's called this because this machine used to have a different core. Like it used to be running an i5 4690K and a Z87 UD3H motherboard, but I took that out and put it in another PC when I upgraded it. And I like to tie the actual name to the core of the machine. So that machine that got the transplant with that is now called Blackthorn, and this one's Lava Ridge. Because this is the root pool, I haven't renamed it yet because I'd have to boot up in an external USB drive or something like that, and I haven't been bothered. But apart from that, it's just a boot SSD. I don't really care about it too much because everything here is backed up and reproducible. But these are my more interesting pools. So I've got these two right here. I've got Ender and Ether. Yep, Minecraft. You know what's going on. So I'll just show you the status real quick. Obviously, all my drives are encrypted. Naturally, that's why there's the .eli. But these ones here, so like you can see, I've got 8 terabytes total in the Ender pool. I've actually got my storage configuration in this machine is one 4 terabyte drive. That's this one right here, and 2 8 terabyte drives. So you might be wondering, where's the 16 terabytes? Well, buddy, they're mirrored because I'm not a silly Billy. So I've got these two 8 terabyte drives. Unfortunately, I don't get 16 overall, but they're mirrored. So that helps with my sanity. And then this one over here is not mirrored. I just dump whatever on there that I don't really care about. Like it's 4 terabytes of mass storage for whatever I need. So that's my storage setup. I'll do the NeoFetch here for you. The uptime is really bad because I updated the server before this video, but I'll do an HTOP as well so you can see what we're working with here. So obviously, because my user's not root, he can't see all of the processes that's running, but I've got quite a lot of threads. And now you might say, Hoff, isn't this a little funny that your server is so cracked when your last video was on programming under constraints? And you're dead right. Okay, you got me there. I like to run a whole bunch of stuff. But hey, my custom services that I programmed have to run on Raspberry Pis. So I do program to constraints, okay? I don't want to see it in the comments. Like, oh, you talked about programming with constraints, but you got a 24 thread server with 32 gigs of RAM. Whatever. Anyway, that's what we got. So it's pretty sweet. And what we're gonna do next, the host is not actually that interesting because nothing really runs on it. The more interesting things are these jails right here. So I'm gonna go over the jails with you in just a second. The first jail on the chopping block is Ruby. So we'll go ahead and log on in. Naturally, Groudon is the Pokemon that comes up. And this jail is more for public-facing services, right? So the vast majority of my services, if I need to expose them over the internet to access them remotely, I do that with SSH port forwarding, which is pretty nice because you can literally just have SSH that will listen on ports and then forward them to your local machine, and you don't have to open them at all on your router. But this jail right here is the one that actually like has most of my public facing services, that being like NGINX, Minecraft, Terraria from time to time. You know, those sort of ones that you do actually open the port for. But yeah, if I just go ahead and do a little ls here, you can see I've got a Minecraft server here. I've got some of the stuff on my website. My website is like labeled as under construction right now. I'm actually cooking so hard. You guys check it out in a little bit, but yeah, cooking. I host a couple of different websites, not just this one, and all that stuff is in www. So that's what this one does. Basically, like game servers, web server. It's pretty simple. Okay, Sapphire is a secret, so I'm not gonna show you guys. Sorry, buddy. But next one is Emerald. So Emerald, this is my project server. So this jail runs my custom infrastructure as well as hosting Gitea, and I'll show you guys Gitea in just a sec. But essentially, this is the one that I use for my personal project. So Gitea is basically a self-hosted Git instance. It's really nice. It's got a web interface that's kind of like GitHub. So Emerald is the one that actually runs that service. It's got MySQL as well that talks to. And it also runs the custom infrastructure that I made. So I'll show you real quick. This right here is a message broker for a distributed system that I made that kind of runs things around here. And that's why I'm excited to show you the Raspberry Pis, because it's a distributed system. So it has daemons that run on my desktop PC, my laptops, my Raspberry Pis, and they all talk to each other to do different things. And this is the message broker for them. I'm not actually going to release this yet because what I want to do is make this thing peer-to-peer instead of having it talk to this central message broker. So when I finish making it peer-to-peer, I'll look at doing a public release, but I'm still going to show off what it can do at the moment. All right, I'm going to show you guys Gitea. To do that, I need to grab the port that Gitea is running on Emerald and chuck it here locally. So I'm going to show you this script that I've got. It's SSH port forwarding. So my firewall does not actually allow Gitea to be exposed to the LAN. What it actually does is it takes the port that it's running on here, which is 9323, grabs the port from Emerald, which is 9323, that's what Gitea is running on, and forwards it locally to my computer here. So that way I don't actually need to expose Gitea in my firewall, so that means other computers on the local area network can't access Gitea. you have to go through SSH. And to do that, obviously, I've got public key authentication. So it's a nice little double punch, right? So for security, like you can use SSH for authentication, and it sets up an encrypted tunnel for you that you can just use. And you don't have to expose the port. So I'm going to go ahead and run it. And if I refresh here, you'll see my Gitea instance. And yes, I'm a Karomi. Here I've got like all my little projects that I'm working on. You can see some of the stuff that I've done on this channel. This is where I'm cooking my little website here. But it's really nice. Like you can see all this sort of stuff. This is the distributed system I was telling you about before. So yeah, it's great. And you can browse the code literally just like, you would on GitHub. And it's all self-hosted, it's all open source, and you can clone it, you can push, you can pull, you can set up different accounts if you want other people to be able to use it. You can make issues, pull requests. It's really, really great. And yeah, I only started hosting it at the start of this year, and it's honestly been absolutely crazy. I would definitely recommend it. Alright, we're currently chilling in our HoffTV bed. Sorry about the mess over there, by the way. But the reason we're here is because of this. This is my bedside table, and apart from my favorite book in the whole wide world, book review coming soon, by the way, we have this right here. So this, not this, the wireless charger, but this guy right here is Snowpoint, and I'll show you logging on in just a minute. But the reason I'm showing you it here is because, my lights just changed automatically. They're on a timer. I guess, what's the time right now? 6:30, yep. But speaking of the lights, that's what I was going to show you. So this right here is a RFID card scanner. And as you might see right over here, I've got some RFID cards. And my custom distributed system, basically what's going to happen is when I scan a card over here, this guy is going to talk to a Raspberry Pi over there on the other side of the room that I'll show you in just a minute, which then controls the lights over Zigbee. So right here, what I'm going to do is scan this one to set the preset to comfy. And as you can see there, my lighting changes like this. And if I want to go ahead and turn them off, like this, and now only my setup is visible. But yeah, this is my custom distributed system, and if I want to turn them back on again, I can go ahead and scan a different one, and now they're back on. So this is really nice, just to have like in bed and stuff. I just want to show you logging into Snowpoint because I think the artwork for this one in particular is really cool. It's Glaceon, and I think that the Pokédex entry here with the bold looks really good. But yeah, basically this guy, his only purpose is to run Swiper, which is the RFID card reader. So I thought I'd bring up the source code of Swiper real quick so I can show you what actually goes into one of these little distributed programs that runs on my little network. And basically what this guy does is, it's for the RPC stuff, it's based on endpoints. So they've got endpoints that that you can hit that do various things. So essentially with Swiper, this endpoint here, if you tap the RFID card reader once, it runs one command. If you tap it a second time, it runs another. Tap a third, it runs another, of course, all configurable. But you can send it this message to reset a cycle back to the original value. And MariaDB, the scheduling service, does that every day so that I start the day fresh with all my cycles reset to their defaults. Then I hit down here, it's got an application loop that just runs in a separate thread. And all this does is reads the code from standard in. The RFID card reader maps, it has a code, then it does a table scan to see whether there's an event associated with that. And if there is, then it'll just go ahead and execute the event. Down here, this is where the actual daemon code is. So here you can see I'm setting up some packet stuff. A lot of this is abstracted in libraries and things, but here you can see I'm setting up the connection, spawning the sockets, initializing with the protocol, making the network loop. So there's a network loop, there's a sonar ping in my protocol, like a heartbeat type deal. And then this just handles network events. So there's some, validation stuff up here, handling message delivery events, because my protocol has guaranteed message delivery. And then it does the whole, check the endpoint thing. And then sends a status message right at the end to let the other client know how the transaction went. So that's pretty much it. That just runs on the Raspberry Pi, does the, handles the RFID events, and it's really cool. I think we can all agree it would be pretty mid if that was the only component of the distributed system. So I can also go ahead and on my desktop over here, change the lights with one single console command. And what this does is it basically joins the network, sends the command, and then leaves. And I can show you that over on Admiral, which is the message broker. running on Emerald. As you can see here, it joins, sends the command to slate port, and then leaves. And if we go to slate port, I'll show you what's what. The way that my light control works is that I'm using Zigbee to MQTT. MQTT is a pub-sub based protocol. My distributed system is more like a remote procedure call type protocol. But I made a bridge client here that bridges the two together. So my custom infrastructure can interact with MQTT if I want. But yeah, like it literally just sends it to this guy here who sets it like that. The reason my lights changed before, I didn't even plan that by the way, is because of this one. This is a real-time scheduling service. So you can see here, all it does is go through a tick. And the tick is every second. And every second, it just does a map lookup in Go. It's written in Go, this one. A lot of them are written in C. Some of them are written in Go. This one's written in Go. It just does a map lookup and sees if there's any events associated with this particular tick and executes. So what I've done is I've reconfigured MarTSS here to send me a dummy test notification once this tick value hits 50 past seconds, that is. Now, it's going to be a little different from what's up here because of clock skew, but overall, I haven't found it to be that big of an issue. So all we got to do now is wait 10 seconds for this tick to hit 50, and you'll see it send me a notification up here in the corner. Just like that. And as you can see back over here in our message broker, at the correct time, we sent a message to radio, which is terrific. The next jail on the list is Soul Silver, so I'll go ahead and log into that. This one is really dead simple. I have a couple of folders here, so cloud and work. Essentially, I use my server as a NAS as well, and a private personal cloud. So I don't subscribe to OneDrive, Google Drive, etc. I just use this. And I'll go over what I actually use to access the files remotely later on in the video. But this Soul Silver right here, essentially some of the computers in my household are Windows machines. And so I wanted a container where I could run a sort of more public, but also still private NAS setup. So it's not my personal files, it's just the stuff that I want to expose to my LAN. And because some of them are Windows PCs, this actually runs SMB, so Samba, basically, so that Windows PCs can access them. I have a work folder here as well because I need to use a Windows VM to do some work from time to time. And it's really nice to be able to just use that Windows VM, mount this network folder, and then have that to transfer files between my Linux machine and my Windows VM and things like this. And yeah, so this machine just has like these two pretty like private but public, right? It's private but public, and it just runs SMB that other computers can look at. By the by, here's my Windows VM, and as you can see, SMB is mounted on the IP address of Soul Silver. So that's terrific. Bit of a goofy moment from me, guys. I realized Heart Gold actually comes before Soul Silver, but I did it after anyway. But Heart Gold's functionality to Soul Silver is essentially identical, bar the fact that it doesn't have SMB. So this is literally just my private personal cloud. And that's what this jail runs. So there's no SMB here. This is only my personal stuff, and only Linux machines are able to access it because I personally don't have any personal machines that run anything else. To do this, I use SSHFS. I have a video already on SSHFS on this channel, but I'm going to do an update at some point because it's a bit outdated. I did it like 2 years ago when I wasn't taking this whole YouTube thing very seriously. But yeah, Heart Gold is the same as Soul Silver. It's a NAS, it's a private cloud, but it runs my personal files. It doesn't have SMB, and I access it remotely over the internet with SSHFS. All right, guys, here's a live demo of what I was just talking about before. So if I run this script here called mount LFS cloud, what this is going to do is call SSHFS in the background, talk to Heart Gold, and mount the private cloud folder over SSHFS. So I do that, and I'll bring my file browser over here, and you can see down here I've mounted a network drive called cloud. So if I open that up, you'll be able to see now I've got access to all of my personal private cloud files, and down there you can see how much I have free, which is of that 8 terabytes. So that is mwah, very nice, very nice. So it's an 8 terabyte personal cloud. I'm pretty chuffed about it. Important thing to mention, it's all encrypted too, because this is a file system over SSH. So when you access it remotely, all of your stuff is end-to-end encrypted. So it's terrific. Okay, moving right along, we have Diamond. Now, Diamond is essentially a guest file transfer thing. So what the deal is here is that it's got SSH password authentication turned on, but I don't have the port open all the time. Basically, if like a friend needs to send me a file or something like that, I'll open it up temporarily, and then it's SSH password authentication. The people that I trust have know what the password is, and then they can just SCP me a file when I need it. But I usually keep this one closed. If I go ahead and do an ls here, I wonder what I'm going to get. Oh yeah, so a friend of mine was basically just sending me a bunch of his Counter-Strike source surf maps because he knows that I like to use it for some of my gameplay. But that's what's on there at the moment. And you can see there, that's the guest user that was sending me that stuff. Naturally, after Diamond comes Perl. And Perl, basically what it does is it runs my personal database. So I mentioned I was running MySQL on Emerald just for Gitea stuff. Well, this runs a personal database that some of that distributed system guys interact with from time to time. And I've got other applications that use this database as well. So it's essentially just a personal database of mine. I use it for various things. So for example, like my uni assessments, I put all my results in there. I've got an event register where it can send me reminders for things. I've got all sorts of stuff. Actually, you know what? Let me see if I can, like it's SSH port forwarding as well. And this is the little script I've got. I called it Marry Me because it's like MariaDB. Technically, it's like, it's not MySQL, it's MariaDB, but they're like equivalent, right? And let me see if I boot up MySQL Workbench over here. I'll see if I'm going to dox myself in any way. No. Okay, I think we're good. So here, yeah, like as you can see, I've got a personal thing. I'm not going to do a table reveal, sorry. But basically here I was just calculating my grades currently going into final exams because I'm on final uni exams at the moment. And I was just calculating up all of the stuff that I've achieved so far, so I know kind of what I need to get on the final exams to pass them all. But yeah, this is the kind of stuff it holds. Like it's sort of that kind of deal. Wow, guys, get excited! Last jail. Here we go. We're looking at Platinum. Now, this one is different from the other ones. This is my Bastion jail. So essentially what I mean by that is instead of having, for instance, Ruby's SSH port open if I want to get in and do stuff, or instead of having Lava Ridge's SSH port exposed to the internet if I want to get in and mess with the host, what I do instead of having every single SSH port open for every single host, because that's a nightmare, I have this guy right here, and his only job is to proxy jump me to other hosts. So this jail right here is the only one out of all of them that has their SSH port exposed to the internet, and its only function, it has nothing else on it. Its firewall is pretty restricted. Its only purpose is to proxy jump me to the other host that I want to use. Now, the lucky last one I'm going to show you guys is Crystal, and this is actually quite different to the other ones because it's not a jail, it's a virtual machine. So it's running on Beehive on my server. Beehive is the FreeBSD hypervisor. And yeah, it's a VM and its only purpose is to run Steam games. So I'm logged on here as the Steam user. I have .steam, Steam apps, common. I've got CS2 server, it's still called Global Offensive for some reason. CS source server for my surf and stuff. I've got Power World and I've got Valheim. Okay, well this officially concludes MTV Crib Tour Server Edition 2024. I hope you guys enjoyed, hope you found it interesting. I hope you had some ideas maybe if you want to host your own stuff. Let me know what your infrastructure is like in the comments. I'd really love to hear about it. Cheers.